question of whether phase A and the high leg of phase B can be used with a 2-pole breaker to power a 208/220 volt appliance, such as a water heater, requires a clear and definite answer no. The high leg of phase B should not be used in this manner. This is because the high leg, often found in 3-phase Y electrical systems, is specifically designed to provide a 208-volt phase to neutral voltage. The high leg itself registers at 240 volts, not 208 or 220 volts like the appliance's voltage requirements. Attempting to power the appliance with a 2-pole breaker using phase A and the high leg of phase B can lead to a voltage imbalance, which can in turn cause significant damage to the appliance. The primary reason for this damage is the incorrect voltage being supplied to the appliance, deviating from its designed operational parameters. A 208/220 volt appliance is engineered to function within a specific voltage range. Deviating from this range by using the high leg, which is 240 volts, introduces an overvoltage scenario which can stress the appliance's components, leading to premature failure or immediate damage. Furthermore, the phase relationship between phase A and a high leg of phase B is not designed to provide a stable and balanced power supply for a 208/220 volt appliance when used with a 2-pole breaker. The proper method for powering a 208/220 volt appliance involves utilizing a 3-pole breaker. This breaker should be connected to phase A, phase B, and the neutral conductor. This configuration ensures that the appliance receives the appropriate voltage and maintains the correct phase relationships, critical for its safe and efficient operation. The 3-pole breaker distributes the load evenly across the 3 phases, preventing the voltage imbalance that would occur if the high leg of phase B were used improperly. In 3-phase electrical systems, the voltage between any 2 phases is typically higher than the voltage between a phase and neutral. This is a fundamental characteristic of 3-phase power distribution. In a Y configuration, the voltage from any phase to neutral is 120 volts or 277 volts depending on the system. The voltage between any 2 phases is 208 volts or 480 volts, respectively. The high leg, also known as the stinger leg or wild leg, is unique to some 3-phase delta systems. In these systems, one of the phases is center tapped, and the voltage from that center tap to one of the other phases is higher than the voltage from that center tap to the remaining phase. This high leg voltage is typically around 208 volts when the phase-to-phase voltage is 240 volts. It's important to recognize the potential hazards associated with misusing the high leg. Its higher voltage can damage equipment designed for low voltages. Therefore, it is crucial to identify and label the high leg clearly to prevent accidental connections. When working with 3-phase power systems, always consult the system's documentation and use appropriate measuring tools to verify voltage levels before making any connections. Incorrect wiring can result in equipment damage, electrical shock, or even fire. Remember, electrical work should only be performed by qualified and licensed electricians who have the knowledge and experience to handle 3-phase power systems safely. Furthermore, adhering to the National Electrical Code (NEC) is essential to ensure safe and compliant electrical installations. The NEC provides specific guidelines for wiring and protection of electrical systems, including 3-phase systems. Consulting the NEC and following its recommendations helps prevent electrical hazards and ensures that the electrical system operates safely and reliably. For example, NEC Section 210.4 addresses multi-wire branch circuits, which are often used in 3-phase systems. This section specifies the requirements for identifying the grounded conductor, connecting devices, and providing overcurrent protection. Similarly, NEC Section 215.12 covers feeder identification requirements, which are crucial for ensuring that the correct voltage and phase are supplied to different parts of the electrical system. NEC Section 408 covers switchboards and panel boards, which are essential components of 3-phase power distribution systems. This section includes requirements for grounding, overcurrent protection, and conductor sizing. Following these NEC guidelines helps ensure that the switchboards and panel boards are installed and maintained safely. In summary, when working with 3-phase power systems, it is crucial to understand the voltage characteristics, phase relationships, and potential hazards associated with the high leg. Always consult the system's documentation, use appropriate measuring tools, and follow the NEC guidelines to ensure safe and compliant electrical installations. Incorrect wiring can result in equipment damage, electrical shock, or even fire. Therefore, electrical work should only be performed by qualified and licensed electricians. To reiterate, the high leg should not be used to power 208/220 volt appliances. The correct method involves using a 3-pole breaker connected to phase A, phase B, and the neutral conductor. This configuration ensures that the appliance receives the appropriate voltage and phase relationships, promoting safe and efficient operation. The use of a 2-pole breaker with phase A and a high leg of phase B poses a risk of voltage imbalance and potential damage to the appliance due to the high leg being 240 volts when the appliance is made for 208 or 220 volts. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're unsure about any aspect of electrical wiring or system design. They can provide expert advice and ensure that the electrical installation is safe, compliant, and meets the specific requirements of the appliance and the electrical system. Now, to elaborate further on the specific components involved in a 3-phase power system suitable for powering a 208/220 volt appliance, let's delve into the roles and characteristics of each part. Firstly, the 3-pole breaker serves as a crucial safety device and switching mechanism. Its primary function is to protect the appliance and the electrical system from overcurrent conditions, such as short circuits or overloads. A 3-pole breaker is designed to interrupt the current flow in all 3 phases simultaneously, ensuring that the appliance is completely disconnected from the power supply in the event of a fault. The breaker's amp rating should be carefully selected to match the appliance's current requirements and the wire's ampacity. Exceeding the breaker's rating can cause it to trip, interrupting power to the appliance, while using a breaker with a much higher rating than the appliance's current requirements can prevent it from tripping in the event of a fault, potentially leading to overheating and damage to the wiring or the appliance. Secondly, the conductors, or wires, connecting the breaker to the appliance must be appropriately sized to handle the appliance's current draw. The conductor size is determined by the appliance's amp rating and the allowable voltage drop. Using undersized conductors can cause them to overheat, leading to insulation damage and potentially creating a fire hazard. The National Electrical Code, NEC, provides tables that specify the appropriate conductor size for various amp ratings and wiring methods. These tables take into account factors such as the conductor's insulation type, the ambient temperature, and the number of conductors in a raceway or cable. It's crucial to consult these tables and follow the NEC guidelines to ensure that the conductors are adequately sized for the appliance's current requirements. Thirdly, the neutral conductor plays a vital role in providing a return path for the current flow in the circuit. In a 3-phase Y system, the neutral conductor is connected to the center point of the Y, which is typically grounded. The neutral conductor carries the unbalanced current, which is the difference between the current flowing in each of the 3 phases. The neutral conductor should be sized appropriately to handle the maximum unbalanced current. In some cases, the neutral conductor may need to be larger than the phase conductors, especially if the load is significantly unbalanced. The NEC provides specific guidelines for sizing the neutral conductor based on the type of load and the expected unbalanced current. Fourthly, the grounding system is essential for safety and for providing a low impedance path for fault currents. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the equipment grounding conductors. The equipment grounding conductors are connected to the metal enclosures of the appliance and the electrical panel. In the event of a fault, the equipment grounding conductors provide a path for the fault current to flow back to the source, tripping the breaker and disconnecting the power supply. The grounding system helps to prevent electrical shock hazards and to minimize the risk of fire. The NEC provides detailed requirements for grounding and bonding electrical systems. Following these requirements is essential for ensuring the safety and reliability of the electrical installation. Fifthly, the appliance itself must be properly rated for the voltage and frequency of the power supply. A 208/220 volt appliance is designed to operate within a specific voltage range and at a specific frequency, typically 60 Hz in North America. Connecting an appliance to a power supply with a voltage or frequency outside of its rated range can cause it to malfunction or be damaged. Before connecting an appliance, always verify that its voltage and frequency ratings match the power supply's characteristics. Sixthly, it's essential to use appropriate wiring methods and materials for the specific application. The wiring method refers to the way in which the conductors are installed, such as in conduit, cable, or raceway. The NEC specifies the allowable wiring methods for different types of occupancies and environments. The wiring materials, such as the conductor's insulation type and the conduit or cable's construction, must be suitable for the environmental conditions such as temperature, moisture, and exposure to chemicals. Using inappropriate wiring methods or materials can lead to premature failure of the electrical system and increase the risk of electrical hazards. Seventhly, proper labeling and identification of the conductors and equipment are crucial for safety and for facilitating maintenance and troubleshooting. The NEC requires that all conductors be identified by color coding or other markings. The equipment, such as breakers, switches, and panels, must be labeled to indicate their function and voltage rating. Proper labeling and identification help to prevent accidental connections and to ensure that the electrical system is operated and maintained safely. Eighthly, regular inspection and maintenance of the electrical system are essential for ensuring its continued safety and reliability. The electrical system should be inspected periodically by a qualified electrician to identify any potential problems, such as loose connections, damaged wiring, or worn-out components. Any identified problems should be addressed promptly to prevent them from escalating into more serious issues. Regular maintenance, such as tightening connections, cleaning equipment, and testing breakers, can help to extend the lifespan of the electrical system and to prevent unexpected failures. By paying close attention to these components and following the NEC guidelines, it is possible to safely and reliably power a 208/220 volt appliance using a three-phase power system. However, it is always recommended to consult with a qualified electrician to ensure that the electrical installation is performed correctly and that all safety precautions are taken. Moreover, the high leg's presence in a three-phase delta system necessitates careful planning and execution during electrical work. The ungrounded nature of the high leg, coupled with its higher voltage to ground, demands strict adherence to safety protocols and code requirements. It is imperative to accurately identify the high leg and clearly label it to prevent accidental connections. Only qualified and licensed electricians should undertake work involving high leg systems, as they possess the expertise to handle the intricacies and potential hazards associated with these configurations. Proper grounding and bonding techniques are paramount in high leg systems to mitigate the risk of electrical shock and ensure equipment safety. Overcurrent protection devices such as fuses and circuit breakers must be appropriately sized and installed to safeguard against overloads and short circuits. Regular inspections and maintenance are crucial to identify and address any potential issues, such as loose connections or damaged wiring. Neglecting these measures can compromise the safety and reliability of the electrical system. The National Electrical Code, NEC, provides comprehensive guidelines for working with high leg systems, covering aspects such as conductor sizing, overcurrent protection, grounding, and bonding. Compliance with these codes is essential to ensure the safety of personnel and equipment. Failure to adhere to code requirements can result in serious consequences, including electrical shock, fire, and equipment damage. In addition to code compliance, thorough training and education are vital for electricians working with high leg systems. They must be knowledgeable about the specific characteristics of high leg systems, including the voltage relationships, grounding requirements, and potential hazards. They should also be proficient in using appropriate testing equipment and safety procedures. Continuous learning and skill development are essential to stay abreast of the latest technologies and best practices in the electrical industry. Furthermore, effective communication and coordination are crucial when working on high leg systems. Electricians should clearly communicate their intentions and procedures to other workers on the job site. They should also coordinate their activities to minimize the risk of accidents and ensure that the work is completed safely and efficiently. A collaborative approach involving all stakeholders can help to identify potential hazards and develop effective mitigation strategies. Finally, it is important to emphasize the importance of documentation and record keeping when working with high-leg systems. Accurate records of the electrical system, including wiring diagrams, equipment specifications, and inspection reports, should be maintained. This documentation can be invaluable for troubleshooting problems, performing maintenance, and ensuring compliance with code requirements. A well-documented electrical system can also facilitate future modifications or upgrades. In conclusion, working with high-leg systems requires a high level of expertise, attention to detail, and adherence to safety protocols and code requirements. By following these guidelines, electricians can safely and effectively install, maintain, and troubleshoot high-leg systems, ensuring the safety of personnel and equipment. So, remember, do not use the high leg for 208/220 volt appliances.